Hello everyone, I am Dr.VRAO-PHYSICAL, Associate Professor and your chemistry learning companion. In general, students who are learning chemistry often feels ambiguity in understanding quantum mechanics. But when we learn it from its origin, that makes you clear, right? When we Before we are going to enter into the details of quantum mechanics, first of all, we all need to know the subject of physics and its branches, because the subject of physics paved the way for quantum mechanics, right? And the subject of physics broadly classified into two categories or two branches, that is classical physics or classical mechanics, right? First one is classical physics, which is also called as classical mechanics. And the second branch is quantum physics or quantum mechanics, right? The subject physics broadly classified into two branches, that is classical physics or classical mechanics. And the second one is quantum physics or quantum mechanics. Now let us see the definitions of these branches, right? Classical physics or classical mechanics is a branch of physics that deals with the macro objects where Newton laws are holds good. I repeat, classical physics or classical mechanics is a branch of physics that deals with the macro objects where Newton laws are holds good. We all know that all the three Newton laws, the first law is law of inertia, and the second one is force is a product of mass and acceleration, and the third law is every action there is equivalent opposite reaction, right? Those three are Newton laws. These three laws are holds good when we concerns with the classical physics or classical mechanics, right? But these Newton laws, now coming to the quantum physics or quantum mechanics. Okay, before we come to know the definition of classical mechanics or quantum mechanics, we need to go through the details of Newton laws and classical mechanics. We know that classical mechanics is a branch of physics that deals with macro objects where Newton laws holds good. Whereas in quantum physics or quantum mechanics is a branch of physics that deals with the micro objects where Newton laws are not holds good. I repeat, quantum physics or quantum mechanics is a branch of physics that deals with the micro objects where Newton laws are not holds good. Right? Right. Then whenever these Newton laws, that means in quantum mechanics, Newton laws are not holds good. That means Newton laws are failed in when we concerns with the quantum mechanics, right? Or right? Now, now let us know what are these macro objects and what are these microparticles? Macro objects are the objects which are having considerable mass. For example, revolver bullet. Revolver bullet is the example for macro object. And a bus and a car, all these are examples for macro objects because they are having large masses which are considerable masses, right? And then what are microparticles? Microparticles are micro objects. It is not a customary way to pronounce as micro objects. It is customary to pronounce as microparticles. Microparticles are the particles which do not have considerable mass. Examples for microparticles are electron, proton. For example, electron. Mass of the electron is 9.1 into 10 to the power of minus 31 kg. Now let us see why this mass is insignificant or not considerable. For example, when we write this standard form into decimal form, this takes 9.1 into 10 to the power of minus 31 kg means when we write this in decimal form, we can get zeros, 0.30 zeros, 0.30 zeros after 9.1. Right? From this, we can understand how minute it is. Right? Another example for microparticle is proton. Mass of proton. Mass of proton is 1.67 into 10 to the power of minus 27 kg. When we write this standard form in decimal form, we can understand how minute it is, right? For example, this is 0.26 zeros after 26 zeros after we can write 16. From this decimal form, we can understand how minute it is. Right? Right. These micro, why I am insisting their masses? Because these microparticles are very interesting. These microparticles are very interesting because these microparticles do have dual nature as like light. I repeat, these microparticles have, these microparticles do have a dual nature as like light. We all know that light has dual nature, and some of the physics experiments such as photoelectric effect, black body radiation, Compton effect, which concludes that these experiments concludes that light has particle nature, right? And we know that some of the physics experiments such as interference, diffraction, polarization, all these experiments concludes that light has wave nature. Therefore, light has, and there are experiments, there are scientific proofs to prove the dual nature of light, that is particle nature as well as wave nature. As like light, these microparticles too have dual nature. Then, do you know which experiment? Do you know which experiment or which concept or which hypothesis concludes that these microparticles have dual nature? Right? The answer is de Broglie's hypothesis. Right? De Broglie's hypothesis concludes that these microparticles do have dual nature. That is, these microparticles behaves like a particles as well as waves. Right? Right. But before the advent of this de Broglie's hypothesis, physicists were mystified with the deep, Bohr's atomic model, right? Before, I repeat, before the advent of this de Broglie's hypothesis, physicists were mystified with the Bohr's atomic model, okay, where electrons are revolving around the nucleus, where electrons are revolving around the nucleus, okay. This is the nucleus where electrons are revolving around the nucleus. Electrons are revolving around the nucleus. But before the advent of de Broglie's hypothesis, physicists were mystified with this Bohr's atomic model, where electrons are revolving around the nucleus in a circular orbits at a fixed length. And we all know that this atomic model is failed to explain uh, spectrum of multi-electron atoms. And this model, that Bohr's model, fails to explain the varying intensities of spectral lines. And the blunder is this Bohr's atomic model does not consider dual nature of electrons, right? These three are major drawbacks in Bohr's atomic model, right? These drawbacks were overcome by after the advent of de Broglie's hypothesis, right? I repeat, after the advent of de Broglie's hypothesis, the drawbacks uh, which are found in the Bohr's atomic model are overcome, right? So the concept, which concept concludes the microparticles have dual nature? De Broglie's hypothesis. De Broglie's hypothesis concludes that these microparticles too have dual nature, right? Therefore, after the advent of this de Broglie's hypothesis, I wish to write de Broglie's name, de Broglie's hypothesis, right? De Broglie's hypothesis. After the advent of this de Broglie's hypothesis, right, the subject physics is bifurcated into two branches, that is classical physics and quantum physics, or in general classical mechanics and quantum mechanics. Therefore, the concept or the de Broglie's hypothesis bifurcated the subject physics into two major branches, that is classical physics and quantum physics. We all know that classical physics is a branch of physics that deals with the macro objects where Newton laws are holds good, right? And quantum physics is a branch of physics that deals with the micro particles where Newton laws are not holds good, right? Now I shall conclude this lecture. I conclude this introduction. Therefore, de Broglie's hypothesis leads to, right, quantum mechanics or quantum physics, right? Therefore, quantum mechanics or quantum physics is a branch of physics that deals with microparticles associated with dual nature. That is, I repeat, quantum physics or quantum mechanics is a branch of physics that deals with the microparticles associated with the dual nature. Associated with the dual nature, right? Therefore, in the next video, we shall go through the details of de Broglie's hypothesis. How de Broglie concludes that electron revolving around the nucleus behaves like a wave as well as a particle, right? In the next video, we shall discuss what is the de Broglie's hypothesis and what are its consequences. Okay, Thank you. Thank you for watching.